Good morning. We are going to discuss about DSP architecture and programming introduction part. The basic thing is that the differences between microprocessors and microcontrollers is that microprocessor is a computer processor which incorporates the functions of computer CPU on a single IC, and microcontrollers, it consists of more CPUs along with the memories and peripherals. DSP processor is a specialized microprocessor unit that needs for DSP functions. Blackfin processor is a type of DSP processor. It has a special function unit called as 16-bit multiply accumulate unit, accompanied on a chip by a small microcontroller. Conventional microprocessor uses only a single memory unit that shared with both address and data memory is shared by a single memory unit. But most DSP chips uses Harvard architecture. It has separate memory spaces for program as well as data. It has a separate program for separate memory allocation for program fetching and data fetching. DSP is a digital signal processing. It has several applications. It is used to extract the important information. So basic block diagram of DSP block diagram. Hardware comparisons in various units: ASIC, FPGA, general purpose processor, and DSP processor. So by comparison performance, flexibility, and power consumption and development time, DSP processor is most suitable for hardware application. It uses DSP processor. It follows Harvard architecture. It has a dedicated single cycle multiply accumulate instruction. Single instruction multiple data. It follows VLIW architecture. It has a zero overhead overlapping and so on. Harvard architecture, as we said earlier, it has a separate memory for data as well as program. DSP algorithm, it is a basic digital FIR filter structures. So the differences between DSP processor and microprocessor, it has the significance of using DSP processor is that it has a single cycle multiply accumulate capability. It can perform convolution operation and convolution operation as like we are doing in DSP algorithms. What we have done in DSP's algorithms, that will be done in a single cycle multiply accumulate unit. It has a specialized addressing modes, memory and execution control, like that. So Analog Devices company provides DSP architectures and programming for by means of two processors they had. One is a Sharp processor and another one is Blackfin processor. Blackfin processor follows micro-signal architecture. It combines both microcontroller and DSP processor. Analog Devices and Intel developed this architecture, say micro-signal architecture. It combines both the capabilities of microcontroller and DSP processor. The advantage of this integrated features is that it does multimedia processing and communication. It is a special ADSP is Analog Devices DSP Blackfin processor. It has a Blackfin processor is a 16-bit fixed point processor that is based on a micro-signal architecture. It consists of several instructions like dual multiply accumulate engines, orthogonal reduced instruction set computer like instruction set, and SIMD, that is single instruction multiple data programming capabilities, and multimedia processing features into a unified architecture. It has a system peripherals PPI, SPI, UART, as the microcontroller, real-time clock, watchdog, timer, and general purpose IO ports and all. DMA controller, in order that it transfers the data from between external devices and memories, and the internal memories without processor intervention. Cache memory is for accessing both data and instruction. It's a Blackfin processor core. It consists of three major units. One is address arithmetic unit, data arithmetic unit, and control unit. Address arithmetic unit, we have level shift DA0, DAG0 and DAG1 stands for data address generator, and buffer unit they have then indexed I0 to I3 stands for index register, L0, L1, 3 register, base register, B0 to B3 base registers, then stack pointer, frame pointer, B0 to B5 pointer registers. That corresponds to address arithmetic unit. In the case of data arithmetic unit, we have 16-bit ALU and two 16-bit ALU and 8-bit ALUs are there. Then accumulator 0 and accumulator 1 and barrel shifters are there, and R0 to R7 totally 8 registers for storing data. And control unit consists of program sequencer and aligning and decode and blue buffer for storage purposes. So data arithmetic unit consists of two 16-bit multipliers, 16 corresponds to 16 multipliers, and 40-bit accumulator, accumulator 0, accumulator 1, it is 40-bit accumulator, 16-bit multipliers, then 4 8-bit video ALUs and barrel shifter for storing data. It has computational units for getting the data from data registers and perform fixed point operations. That is, data is gathered from data arithmetic unit and do the processes in a fixed point operations. So the function of data registers to receive the data from the data buses and transfer the data to the computational units for processing. It performs DSP algorithm, AFR filtering, FFT, and so on. Arithmetic logic unit denoted logical, both arithmetic and logical operations has been done using 16-bit data or 32-bit data. Barrel shifters, the function of barrel shifter is to perform logical and arithmetic shifting, rotation, normalization, extraction, whatever the operations has been done in the accumulator unit, that will be the manipulation of shifting operation, rotation, normalization, all the thing is done at the barrel shifter. So compute register file, it contains 8 32-bit registers. It processes 8 or 16 or 32-bit data. Here we have signed, unsigned formats, rounding, saturation. All the major significance of Blackfin processor is that multiply accumulator unit. Multiply accumulator unit has been performed. Multiply accumulator unit 16 by 16 multiply operation is done, and the results will be stored in multiply operation. 16-bit by 16-bit multiply operation is done, and the result is stored in a 40-bit accumulator unit. So that is a major advantage of Blackfin processor. And it supports signed, unsigned format, rounding, and saturations are supported. For the program sequencer controls the flow of instruction execution. If it is run, the entire address of the data arithmetic unit, whatever the data is manipulated from the data arithmetic unit, that will be the corresponding address is located in the address arithmetic unit. The program sequence flow will be controlled by the control unit. The data manipulation, the data stored in the arithmetic unit in various registers, accumulators, by using multiply accumulate unit, multiplication operation, accumulate operation. This is significance of this processor. Multiply accumulate unit, and barrel shifter is for shifting purposes or controlling the purposes. Then registers are stored in the data, and the corresponding address is located in the address arithmetic unit. And both the address and data arithmetic unit, the control operation will be done in the control unit. The address arithmetic unit provides two addresses for simultaneous dual fetches for memory. It contains index register, index modify, and length and base register. So here we have several registers. One is index I0 to I3 stands for index length register, L0 to L3 corresponds to length register, B0 to B3 corresponds to base register, M0 to M3 corresponds to modify registers.